Go.
All right, so investigation 4, INV 4, is where it's at today. That's page 271. We're talking about geometric solids. And I just want to identify some stuff with you, just kind of run you through what you're doing today. It's not really a hard deal today. It's actually quite, it's quite simple. So the first thing we're doing is talking about, write the word geometric solids down. Just squeezing the eye, because I skipped it. All right? Okay, a geometric solid is a solid that occupies space. Okay, it occupies space. It's not something that you draw on a piece of paper. These turkey things on your tables that you're making for that dinner are geometric solids. They occupy space, right? They're not just a drawing on a piece of paper. They were, and now they're not, right? So, even though you can't see that on the video, there you go. All right, so they occupy space. There are 3 terms that we want to identify when we're talking about a geometric solid. That is face, is the first term. The face is the flat shape that makes up the geometric solid. So this is the flat face. Of a solid. It makes a shape. It makes a polygon. For example, the flat face of a cube is a square. One of the flat faces of a pyramid is a triangle. There's also a square on the bottom. All right? A sphere has no face, by the way. An edge is the next one. An edge. An edge of a geometric solid are where 2 faces meet. It's the line where 2 faces meet. Faces, gee, Willikers, can't write today. Where 2 faces meet. It's a line where 2 faces meet. And then the vertex, the final one I want you to write down, is a corner. Vertex is a corner. So here is an example. What did I just draw?
A square.
I just draw a rectangle. Drew a rectangle. That is a face. Okay? Let's change that to a 3-dimensional shape. Although it's not going to be very well. All right. Now I made it 3-dimensional. Made it look like it's 3-dimensional, even though it's still flat. All right, so a face, I'll write them by an F. There's 3 that we could see. There's more that we can't see. The bottom that we can't see, the other side, the left side of this one, and the back side. They're all the rectangles that make up this shape. Okay? The edge, I'll signify with the letter E, is all the lines that make up this stuff. So notice the E goes everywhere. Look at all those edges that we can see. There's stuff that we can't see on this one. Okay? I'll change the color for the vertex. Vertex I'll signify with a V, and I'm going to write a V on each one. They're all those corners. that we can see. Okay? How many vertices, that's the term plural for vertex, how many vertices do you see on that shape?
7.
I should say, how many are there? Including the one that you can't see.
Oh.
How many are there? 4 on top, 4 on bottom, including the one that you can't see. That would mean that there are 8, right? How many edges are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 on the back, 12. 12 edges. How many faces?
6.
6. Okay? Does that make sense? In your book, on page 271, it has drawn out polyhedrons, which is a general term for shapes. Take a look at that. It has drawn out prisms, which is a type of polyhedron with parallel congruent bases. So the bases and the tops are the same. A pyramid, which usually has a square bottom and triangular faces. A cylinder, which is like a soup can. It's made up of 2 circles and then some height to it. A cone, and then a sphere. Notice a sphere is different than a lot of those. So is a cone. You have some different stuff to that. All right, so for today, for this investigation, to do this investigation, it's pretty easy. Number 1 says a triangular prism has how many faces? So it's drawn out. It looks like a piece of cheese. It's drawn out. Count the faces, count the edges, count the vertices. For number 2, name those solids. Then it steps you through on how to draw them. Okay, you see that? So you're going to read through that and step through how you draw that. How to draw the polyhedrons and how to draw cones and that kind of stuff. And what you want to do is I want you to go through and try all the way up through activity 3. You stop where it says extensions. Don't do that part. Okay? Any questions? It's really not a complex, you're not going to really need a general math paper for this one. All right, any questions on this? It's not too hard. So read through it, step you through it, okay? I wanted to get the terms down before we moved on. Okay? The rest of it is read and practice the drawing yourself. I think you can handle that. All right, cool. Done.